At exactly 4:15 UTC, something happened that should never have been possible, and if the data is real, it doesn't just challenge science, it breaks it. The laws of thermodynamics, the very rules that control how matter behaves across the universe, appeared to stop applying for just under a minute. This isn't speculation or exaggeration. This is based on live data coming directly from the James Webb Space Telescope and the Deep Space Network. For months, astronomers had been tracking an object known as 3I Atlas. It was classified as a comet, a typical one at that. A fragile mix of ice, dust, and frozen gases drifting through space with a glowing tail of vapor trailing behind it. That's exactly how comets behave. That's what physics predicts. That's what every model confirms. But in less than 40 seconds, that object stopped being a comet. Pause for a moment and really think about that time frame. 40 seconds. In that brief window, the entire surface of 3I Atlas underwent a complete transformation. The spectral data, which had consistently shown signatures of water, ice, ammonia, and methane, suddenly dropped to zero, not gradually, not over time, instantly. The tail disappeared. The outgassing process shut down completely, as if someone had turned off a switch. And then the readings changed. The instruments aboard the James Webb Space Telescope, specifically its near-infrared spectrograph, began detecting something entirely different, a rigid crystalline lattice made of highly compressed carbon, organized, structured, unnatural in its precision. In simple terms, the object didn't just freeze or dry out. It petrified. It transformed from a loose, icy mass into a solid structure with a surface hardness approaching that of diamond. Imagine holding a snowball in your hand. Now imagine that, without any heat, without pressure, without any visible cause, that snowball suddenly turns into a solid block of granite or even diamond. That doesn't happen in nature. It can't. Phase transitions like that require time, energy, and extreme conditions, often millions of years deep within planetary interiors. And yet, this happened instantly, at a distance of 180 million kilometers from Earth, in the vacuum of space where pressure is nearly non-existent. 3I Atlas reorganized its atomic structure in under 40 seconds. The probability of that happening naturally is effectively zero, not unlikely zero. And the data didn't stop there. Observations from the Chandra X-ray Observatory confirmed something even more disturbing. As the object hardened, its density increased, its mass increased, it became heavier. That alone defies basic physics. In a closed system, mass doesn't just appear out of nowhere. There has to be a source, an input, an exchange. So now, we're faced with a possibility that scientists are struggling to even say out loud. If this is a natural event, then everything we know about planetary science is incomplete. But if it isn't natural, then what we're seeing isn't random. It's intentional, because what we witness doesn't look like a breakdown. It looks like a transition, a shift, almost like a system activating. The object didn't collapse, it hardened. It didn't lose structure, it gained it. It didn't behave like something dying. It behaved like something preparing. And that raises a question that becomes harder to ignore with every new data point. What if this object didn't just change? What if it chose to? To understand why this event has completely silenced control rooms at NASA and the European Space Operations Center, you need to understand what 3I Atlas was expected to be. For decades, the standard model for comets has been the dirty snowball theory, first introduced by Fred Whipple in the 1950s. According to this model, comets are loose, fragile collections of dust and frozen gases like carbon dioxide and methane. As they move closer to the sun, they heat up. The ice turns directly into gas in a process called sublimation, releasing material into space. That's what creates the glowing coma and the long flowing tail. It's chaotic, it's messy, and most importantly, it's a process of loss. Comets shed material as they travel. But what happened here was the opposite. At 4:10 UTC, just minutes before the event, everything appeared normal. The James Webb Space Telescope was running a routine spectroscopic scan using its near-infrared spectrograph. The data showed clear absorption lines for water vapor and hydroxyl, exactly what you would expect from a typical comet. Nothing unusual, nothing out of place. Then, 5 minutes later, the data flipped. The water vapor signal didn't fade, it vanished. Completely. At the same moment, the near-infrared camera detected a dramatic increase in reflectivity, also known as albedo. Normally, comets are extremely dark, reflecting only about 4% of the sunlight that hits them, similar to charcoal. But suddenly, 3I Atlas was reflecting 85% of incoming solar radiation. To put that into perspective, fresh snow reflects around 80%. A polished mirror reflects about 90%. This object went from nearly invisible to almost perfectly reflective in seconds. It didn't just stop behaving like a comet, it became something else entirely, something structured, something precise. Naturally, the first assumption was instrument failure. Sensors glitch, data can be corrupted. That's the rational explanation. But this is where the situation becomes impossible to dismiss. Because it wasn't just one telescope. While the James Webb Space Telescope detected this transformation, the European Space Agency's Euclid telescope was also observing the same object during a calibration pass. Independently, using a completely different system, it recorded the same sudden spike in brightness without any surrounding coma. No gas, no dust, just a sharp, solid point of light. And then came the third confirmation. The ALMA Observatory in Chile, using radio wavelengths, analyzed the object's thermal behavior. If 3I Atlas were still a comet, it would display a specific thermal pattern consistent with ice. But ALMA detected something else entirely: thermal inertia, matching dense crystalline carbon. 3 independent systems, 3 different methods, one identical conclusion: the comet was gone. What remained was something solid, dense, and unnaturally ordered, a structure that closely matches a rare form of hexagonal diamond. And when you consider the physics required to create diamond, the situation becomes even more difficult to explain. On Earth, forming diamond requires extreme pressure deep within the mantle or the violent shock of a meteor impact. But this transformation happened in open space. No pressure, no impact, no heat source. And it happened in under 40 seconds. And just when it seemed like this couldn't get any stranger, the object's motion began to change. Not from gas jets, not from outgassing. That had already stopped. This was something else entirely. Because the data suggests that the object didn't just change its structure, it changed its mass. And that leads to a theory that is beginning to take shape among scientists, one that challenges the very assumption we started with. What if 3I Atlas was never just a comet? What if the ice wasn't its true form, but a temporary disguise? And if that's true, then what we're seeing now isn't a transformation. It's a reveal. And in the next part, we're going to break down the moment scientists realized this object wasn't just changing, it was behaving with precision and possibly with purpose. If what we saw was just a surface transformation, it would already be enough to shake the foundations of modern physics. But the moment scientists began digging deeper into the data, it became clear this wasn't just a change in appearance. This was something far more controlled, far more precise, and far more unsettling. Because Just 10 minutes after the initial event, at 4:20 UTC, new spectral data came in, and what it revealed forced researchers to consider a possibility they had never seriously entertained before. The surface of 3I Atlas wasn't just hardened, it was perfect. Not naturally smooth, not worn down over time, but geometrically smooth. No pores, no fractures, no irregularities, a flawless, continuous structure. In nature, that level of perfection doesn't exist. Even the most polished natural formations have imperfections, rough edges, randomness, chaos. But this object had none of that. It was as if the entire outer layer had been engineered, not formed. And that's where the idea of the shell theory began to take hold. What if the comet we had been observing for months wasn't the real object at all? What if the ice, the dust, the gases, everything we thought defined it were just a temporary coating, a layer designed to be discarded at the right moment, revealing something hidden underneath? Because when the data from 4:20 UTC was analyzed in full, one detail stood out above all else. The structure wasn't just solid, it was resilient. The reflectivity remained extremely high, the thermal signature stayed stable, and there was no sign of degradation. This wasn't a natural crust forming under stress. It was a stable, finished surface. And when you see that level of order emerge instantly from what was previously chaos, it points to one thing: an organizing mechanism, something guiding the process, something controlling it. But if that realization wasn't enough to unsettle the scientific community, what came next removed any remaining comfort. Because while researchers were still trying to process the surface transformation, another dataset came in, this time focused on motion. And this is where the laws of physics didn't just bend, they broke. In theoretical physics, there are certain principles we treat as absolute, not theories, not models, laws. One of the most fundamental is the conservation of angular momentum. It's the reason a spinning figure skater rotates faster when they pull their arms inward. As mass moves closer to the center, rotation speeds up. It's a rule that applies everywhere, from spinning atoms to entire galaxies. So when 3I Atlas condensed from a loose icy body into a dense compact structure, its rotation should have increased dramatically. It should have spun faster, maybe even violently. But that's not what happened. According to light curve data collected from ground-based observatories, at the exact moment the surface hardened, the object's rotation didn't accelerate, it didn't even slow down gradually. It stopped. Completely. Before the event, 3I Atlas was tumbling through space, rotating irregularly across multiple axes, completing a full cycle roughly every 8 hours. That kind of chaotic motion is typical for a comet. But in less than 2 minutes, that motion vanished. The object transitioned into a perfectly stable, non-rotating state. No wobble, no drift, nothing. Just stillness. And to understand how impossible that is, you need to consider what it takes to stop something that large from spinning in the vacuum of space. There's no air resistance, no friction, no natural braking system. To cancel that rotation, you need force, massive force, applied with extreme precision. The estimated energy required to counter that motion is around 10 to the power of 14 joules. That's roughly equivalent to the energy released by a tactical nuclear weapon. And yet, there was no explosion, no burst of heat, no debris, nothing that would indicate energy being released in a conventional way. Even more concerning, the object remained cold. If this had been a natural collapse or internal shift, the energy would have converted into heat. The object should have lit up in the infrared spectrum, glowing intensely. But observations from ALMA confirmed the opposite. The temperature stayed low, stable. So now we have 3 separate violations happening at once. A rapid phase change that shouldn't be possible. a sudden stop in rotation that defies momentum, and no detectable heat release, which contradicts thermodynamics, unless the energy wasn't lost, unless it was redirected. This is where a theory began circulating quietly among researchers, a concept so unusual that it's only being discussed in private channels. The idea of a phase change battery. We already know that phase transitions can store energy. Ice melting into water absorbs heat. Water turning into steam absorbs even more. These are basic principles. But what if this transformation wasn't random? What if it was designed to capture and store energy? What if the rotational energy of the object, the energy of its spin, was somehow absorbed and converted into the crystalline structure itself? Because when scientists looked closer at the composition of that structure, they found something even more unusual. It wasn't just pure carbon. It was doped carbon, embedded with trace elements like silicon and boron. In human technology, that combination has a specific purpose. We use doped materials to build circuits, semiconductors, microchips. This wasn't just a hardened surface, it was structured in a way that resembles engineered materials used in high-performance electronics. And nature doesn't do that. Nature doesn't create perfectly doped crystalline lattices with precise ratios. Nature doesn't build circuits, but this did. And when you combine that with the fact that the object stops spinning without releasing heat, the picture starts to change. It no longer looks like a natural transformation. It looks like a system that absorbed its own kinetic energy to power a structural upgrade, like a machine switching modes, like a fortress sealing itself. And then came the next detail, one that made the situation even harder to ignore. After stabilizing, the object didn't just stop rotating randomly. It locked into position. One side of it became fixed, consistently facing Earth. In astronomy, we call this tidal locking. It's what causes the moon to always show the same face to our planet. But tidal locking takes millions of years of gravitational interaction. 3I Atlas did it in minutes. It chose an orientation and held it. And from that moment on, it wasn't just reflecting sunlight anymore. It was doing something else entirely. Because shortly after this stabilization, a new signal began to emerge. A faint vibration, a low-frequency pulse, something coming from inside the object itself. And in the next part, we're going to break down that signal, because what scientists detected wasn't random noise. It was structured, rhythmic, and disturbingly familiar. That signal didn't arrive with a flash or a warning. It started quietly, almost easy to dismiss, just a faint irregularity buried inside the noise of deep space. But within minutes, it became impossible to ignore. At exactly 5 UTC, the Deep Space Network picked up a resonance coming from inside the newly hardened shell of 3I Atlas. It wasn't a burst. It wasn't interference. It was a steady, repeating vibration, a low-frequency pulse that held its pattern with perfect consistency. And the moment scientists isolated that frequency, the room changed. Because it matched something we know extremely well. It matched the resonant frequency of quartz crystals, the same principle used in precision timing devices, the same foundation behind watches, computers, and communication systems. In simple terms, this object wasn't just emitting noise. It was keeping time. Let that sink in. A structure that, minutes earlier, had been classified as a comet was now producing a controlled rhythmic signal identical to the kind used in engineered timing circuits. This wasn't random. It wasn't chaotic. It was stable, predictable, designed. At that point, the conversation began to shift in a direction no one was comfortable with. Because rocks don't keep time. Comets don't generate synchronized pulses. And natural objects don't suddenly behave like precision instruments. Which leads to a question that becomes harder to ignore the longer you look at the data. If this isn't just a rock, then what is it? Because what we're seeing now doesn't resemble a dead object drifting through space. It resembles a system that has powered on. And like any system coming online, it didn't stop at one function. It escalated. By 5:42 UTC, another layer of data came in, this time from the James Webb Space Telescope's mid-infrared instrument. And what it revealed removed any remaining doubt that this was a natural phenomenon. The telescope detected heat, but not the kind of heat you'd expect. The outer shell of the object remained cold, exactly as previous readings had shown. That alone was unusual, considering everything that had already happened. But what lay beneath that shell told a completely different story. There was a pattern, a clear, structured pattern of thermal hotspots arranged beneath the surface, not scattered randomly, not flowing naturally, but organized into a geometric grid. 6 distinct points were positioned evenly around the object's equator, with a central concentration at the pole, the same pole that had been locked facing Earth. And those hotspots weren't static. They were pulsing, on, off, in perfect synchronization. Now, in nature, heat doesn't behave like this. It spreads, it diffuses, it moves unpredictably from hot regions to cold ones. You get gradients, not patterns. You get chaos, not symmetry. But this wasn't chaotic. This looked controlled. It looked like energy being routed, like current moving through a circuit. And the more scientists studied the thermal data, the more uncomfortable the comparison became, because the image didn't resemble a geological structure, it resembled a circuit board under load. A system actively distributing energy across specific nakat, maintaining balance, preventing overload, and then just 3 minutes later, the next piece fell into place. At 5:45 UTC, the Deep Space Network detected a modulation in the background radio spectrum. At first glance, it didn't look like a signal. There was no message, no encoding, no variation that suggested communication in the traditional sense. It was a carrier wave, a pure tone, broadcast at 1.42 GHz, the hydrogen line. This frequency isn't random. It's one of the most important markers in the universe. Hydrogen is the most abundant element in existence, and this specific frequency is considered a universal constant. It's the one frequency scientists have long believed would be used by any advanced civilization trying to signal across space. And now, it was coming from inside this object. But here's the part that changes everything. The signal wasn't steady. It was pulsing, and those pulses were perfectly synchronized with the thermal grid beneath the surface. Heat pulse, signal pulse. Heat pulse, signal pulse. Like a heartbeat. Like a machine cycling up. The pattern was unmistakable. This wasn't random emission. This was coordination. The internal heat system and the external radio signal were linked, operating in lockstep as part of a larger process. And when scientists measured the energy output of those pulses, the numbers didn't just surprise them, they stunned them. Each pulse carried an energy output equivalent to the total electrical production of an entire nation, not spread out, not dissipated, focused into a beam less than 1 degree wide. That beam is now sweeping across the inner solar system. At this point, the idea that this could be a natural event becomes almost impossible to defend. When you combine the hardened diamond-like shell with this internal energy grid, a new picture starts to form, one that is far more structured, far more deliberate. The transformation we witnessed earlier wasn't random. It was preparation. The carbon crystallization wasn't an accident, it was a redesign. The outer shell didn't just harden for durability, it became something else entirely, a thermal conductor, a heat management system, a a protective layer built to handle extreme internal energy without failing. And in physics, there's a reason you would do that. You build a shell like that when you're trying to contain something powerful. Something that generates heat faster than it can naturally dissipate. Something like an engine. Because diamond, as it turns out, isn't just hard, it's one of the best thermal conductors known. If you needed to move massive amounts of heat away from a central core quickly and efficiently, you couldn't choose a better material. So the question becomes unavoidable. What is generating that kind of energy inside this object? And more importantly, why now? Because whatever is happening inside 3I Atlas isn't slowing down. The pulses are increasing in strength. The thermal grid is expanding. The signal is growing stronger with every cycle. This wasn't the end of the event. It was the beginning. And if this is a system powering up, then the most important question isn't what it is right now, it's what happens when it reaches full capacity. Because in the next phase of data, something else emerges, something that shifts this from a mysterious object into something that might be moving with intent. And once you see that movement, once you understand what it's doing, you'll realize this situation is no longer just about observation. It's about trajectory. Up to this point, you could still argue if you really tried that everything we've seen might be some extreme, once-in-a-lifetime cosmic anomaly. Unlikely, yes. Unprecedented, absolutely. But still, maybe, just maybe, natural. A strange alignment of physics we don't yet fully understand. But that possibility ended the moment the next set of data came in. Because what happened after the signal began pulsing wasn't just unusual, it was intentional. By the time we reached 542 UTC, the thermal grid inside 3I Atlas had fully stabilized. The 6 Nikath around the equator were no longer fluctuating randomly. They were locked into position, pulsing with perfect timing, feeding energy toward a central mishwar at the pole facing Earth. Everything about this structure suggested coordination, not chaos. And then, at 5:45 UTC, the signal intensified. The carrier wave at 1.42 GHz didn't change frequency, but its amplitude began to rise in direct sync with the thermal pulses. This wasn't background radiation anymore. It was focused, directed, measured. It was being controlled. At this point, the comparison to a power system becomes unavoidable. In engineering, when a system powers up, it goes through stages: initialization, stabilization, load balancing, and then, finally, full output. What we were watching matched that sequence almost perfectly. The outer shell had already hardened into a diamond-like structure, acting as both armor and a thermal conductor. The internal grid was distributing energy efficiently, preventing overload. And now, the system was broadcasting, sending out a controlled, repeating signal at a universal frequency. This wasn't random behavior. This was a process. And when you step back and look at all of it together, one conclusion begins to form, whether scientists want to admit it or not. 3I Atlas didn't just transform, it activated. Because everything about this sequence suggests preparation for something else. The shell wasn't just protection, it was insulation and heat management. The internal grid wasn't just generating energy, it was regulating it. And the signal wasn't just noise, it was a carrier, possibly waiting to be modulated, possibly already being detected somewhere else. Which raises a question that becomes harder to avoid. If this is a system coming online, what is its purpose? There are only a few possibilities, and none of them are comforting. The first is propulsion. If that internal energy is being used to move the object, then what we're looking at is no longer a passive body drifting through space. It becomes an active one, a controlled one. And with the amount of energy being generated, the potential for acceleration is far beyond anything we would expect from a natural object. The second possibility is communication. That 1.42 gigahertz signal isn't just any frequency, it's the hydrogen line, the most universal marker in the cosmos. If you wanted to send a signal that any advanced civilization could recognize, that's the frequency you would use. So the question becomes, is this object broadcasting a message, or is it announcing its presence? And then there's the third possibility, the one that scientists are the most hesitant to even discuss: weaponization. Because when you combine extreme durability, massive internal energy, and controlled output, you don't just have a signal source, you have something that can direct energy with precision. The beam width detected less than 1 degree isn't wide, it's focused. That's not how natural emissions behave. That's how targeting systems behave. Now, that doesn't mean this object is a weapon, but it does mean it has the characteristics of one, and in science, when something looks, behaves, and functions like a system we already understand, we don't ignore that pattern.